The conduct and publication of the results of such research in the form of the two manuscripts that you mentioned has focused considerable public attention on the issue of dual-use research, namely research that is directed at providing new information critical to the public health, but at the same time has the potential for malevolent applications. Yet influenza has animal reservoirs, especially in birds, and these viruses can undergo extensive genetic changes and jump species, resulting in an influenza virus to which humans are highly vulnerable. There is a clear and present danger that we will have another pandemic, since these viruses continue to circulate in the world and are constantly evolving towards pandemic capability, as we have seen in 1957, 68, and 2009. Indeed, nature itself is the most dangerous bioterrorist, and even as we meet today, H5N1 and other influenza viruses are naturally mutating and changing with the potential of a catastrophic pandemic. This is not a theoretical danger. It is a real danger. For decades, NIH has supported basic influenza research included on transmissibility, host adaptation, and virulence. The goal is to anticipate what the virus is continually trying to do on its own in the wild and to prepare for it. Kawaoka and FAUCI constructed variants of H5N1 avian influenza in order to identify which genetic mutations might alter the transmissibility of the virus. In their studies, they employed a standard influenza animal model, namely the ferret. This slide shows the basic design of the experiments in which the virus was modified to allow for aerosol transmission from one ferret to another. I might point out that one of the causes of the public misunderstanding was the widespread belief that the virus that was transmitted by aerosol from one ferret to another actually killed the ferrets, when in fact that was not the case. We feel that these studies provide critical information, and it was important to determine if H5N1 virus that has this enhanced transmissibility would remain sensitive to existing anti-influenza drugs and vaccines. In addition, and importantly, knowledge of the genetic mutations that facilitate transmission may be critical for global surveillance of emerging influenza viruses. Yet, since transmissibility of a virulence virus was increased, this constitutes dual-use research of concern, or DURC. It does call for us, as you mentioned, to balance carefully the benefit of the research to the public health, the biosafety and biosecurity conditions under which the research is conducted, and the potential risk that the knowledge gained from such research might fall into the hands of those with ill intent. The ultimate goal of the NIH in its embrace of this new policy is to ensure that the conduct and communication of research in this area remain transparent and open at the same time as the risk-benefit ratio of such research clearly tips towards benefiting society. The public, which has a stake in the risks as well as in the benefits of such research, deserves a rational and transparent explanation of how these decisions are made.